Hello, fellow chemists. In this video, we're going to take a look at the number mole or Avogadro's number. This is labeled as a basic video because there's really nothing that you need to understand to be able to follow along with what I'm going to be talking about. So what is a mole? No, not that kind of a mole. The mole is just a number. So when you think of the word dozen, hopefully when I say that word to you, the number 12 pops into your head. The word dozen is associated with the number 12. If you have a dozen donuts, that means you have 12 donuts. If you have 2 dozen donuts, that would just be 2 times 12, and that would be 24 donuts. Well, the word mole is just a number, like the word dozen. And the number that mole represents is a huge number. It's not something small like 12. The number mole represents 6.022140076 times 10 to the 23rd. Now, chemists don't remember it out to that many numbers usually, so we just round it to 6.022 times 10 to the 23rd. And that's the number that you're going to want to remember for this course. 6.022 times 10 to the 23rd. Of what? It could be of anything. It could be 6.022 times 10 to the 23rd chickens, or donuts, or rocks. So all you're doing is you're associating this number with the word mole. Now, this number is also called Avogadro's number, and that's because in 1811, a scientist named Mole Avogadro was doing some research with the volume of gas in balloons, and he started to come up with the concept that amount of atoms or number of atoms could be quantified. And then later in 1911, Robert Millikan, he kind of finalized and came up, or in the 1900s, Robert Millikan finalized this number by taking a Faraday and dividing it by the charge of an electron, and he came up with 6.022 times 10 to the 23rd. So when you see these three terms, either mole, 6.022 times 10 to the 23rd, or Avogadro's number, they all mean the same thing. So why is this number so big, and what really does it represent? Well, in the world of chemistry, you can think of it as a lot like the world of cooking. Whenever you cook something, you have certain ingredients, and you have to mix them together in very specific amounts and put them under certain conditions, usually higher temperatures, and then you get some kind of a food product as a result. Well, in chemistry, it's the same thing. You take very specific amounts of certain elements, mix them together under certain conditions, usually certain temperatures, and they will react and form new compounds. Well, in order to do that, you need to know how much of each element you're working with. And the problem is, each of the elements are extremely small and extremely light. To give you an example of this, if we look at just carbon, one carbon atom, just one individual carbon atom, only weighs 1.99 times 10 to the negative 26 kilograms. There's no scale on Earth that can measure 1.99 times 10 to the negative 26 kilograms. So how are you going to be able to accurately measure out a certain amount of carbon if you want to react it with something? Well, you measure it out in batches. What are the batches? Moles. So you measure out a mole of carbon. Well, that's a little bit more easy to measure because a mole of carbon weighs 12 grams. A mole of hydrogen weighs 1 gram. A mole of oxygen weighs just about 16 grams. So if you measure the atoms out in amounts of moles, it becomes a lot easier to work with them in the units that we're accustomed to, like grams or kilograms. So that's why the number mole has to be so large. It's taking something that's extremely tiny, like how much atoms weigh, and kind of grouping them together in these large numbers so that there's enough of them so that they weigh enough for us to measure on, say, scales in the units of grams or kilograms. Now, one thing that's going to be very important for you to be able to do is to correctly multiply and divide by the number mole, or 6.022 times 10 to the 23rd. So let's take a few examples of just multiplying simple numbers by a mole or dividing simple numbers by a mole to make sure that whatever calculator you're using, you're getting the correct answers. So if you take 2 and multiply it by the number mole, you should get an answer of 1.204 times 10 to the 24th. And again, you might get, depending on how your calculator rounds, you might get 1.205 or 1.203. That's fine. The important thing is that you're getting times 10 to the 24th. If you're not getting that, you're putting the numbers incorrectly into your calculator. Now, when you divide, if you take 4 and divide it by the number mole, 6.022 times 10 to the 23rd, you should get 6.6423, and then a couple numbers after that, but that's not super important, times 10 to the negative 24th. If you are getting anything other than these numbers, especially the exponents, you are putting the number mole incorrectly into your calculator when you multiply it and divide it. And the reason I give you these two examples is because if you are not getting the answers that I'm getting here, you need to take a look at your calculator and make sure that you are figure out how to accurately put in numbers with large exponents to multiply and divide them, because we're going to be doing that quite a bit as we move forward in the course. All right, that's it for this lesson. I hope you learned something. If you did, like and subscribe, and I'll see you in the next video.